Hello grade 12s. Today we look at measures of spread. These can also be referred to as measures of dispersion. Lebo and her friends have collected data on the amount of monthly allowance given to their classmates. Lebo will use this data to ask her parents for a raise in her monthly allowance. In a previous lesson, they looked at the mean, median and mode of data. In this lesson, we will look at the spread of the data. The range is one of the measures of dispersion and is equal to the highest value minus the lowest value. A small range shows that our values are grouped closely together. A large range shows that the values are spread far apart. The problem with range is that it doesn't tell us much about what is happening with the data in the middle of the range. To find out more about the data in the middle of the set, we can use the interquartile range. The interquartile range is equal to the upper quartile minus the lower quartile. This is often written as Q3 minus Q1. As you can see, to find the interquartile range, we need to first determine the quartiles. Quartiles divide our data set into 4 equal groups. To do this, we first find the middle or median of the data. The median is also the second quarter or Q2. Remember, to determine the median, we first write out all the values from the lowest value to the highest value. To determine the lower quartile, we find the middle value of the lower half of the data. To determine the upper quartile, we find the median of the upper half of the data. Now that we've revised how to find the quarters, let's find the interquartile range of Lebo's set of data. Lebo collected data on monthly allowances in Rand from 2 classes, Class A, 100, 30, 40, 70, 200, 150, 100, 60, 100, 100, 100, 200, and Class B, 30, 200, 200, 160, 90, 80, 70, 60, 150, 120, and 100. Let us find the quartiles of the 2 classes. We'll start with Class A. We first write out our numbers from the smallest to the largest. We then determine the median, which is Q2. We have 2 values in the middle, so we add them and divide by 2. Q2 is equal to 100 plus 100 divided by 2, which equals to 100. We now need to find the value of Q1. This is the median of the values to the left of Q2. There are 2 values in the middle of the first half, so we will add them and divide by 2. Q1 is equal to 60 plus 70 divided by 2, which equals 65. The last value we need to find is Q3, the median of the values to the right of Q2. So Q3 is equal to 100 plus 150 divided by 2. This equals 125. Let's put this into a table. The lowest value is 30, Q1 is 65, Q2 is 100, Q3 is 125, and the highest value is 200. Why don't you try find the quartiles for Class B? Well, let's see how you did. For Class B, the lowest value is 30, Q1 is 70, Q2 is 100, Q3 is 160, and the highest value is 200. The 2 sets of data have the same range of 170 and the same median of 100 Rand, but their first and third quartile values are different. A closer look at the 50% of the values between Q3 and Q1 shows that 50% of learners in Class B had an allowance between 70 Rand and 160 Rand, while in Class A, 50% of the learners had allowances between 65 and 125 Rand. Therefore, Class B overall received slightly better allowances. The 5 sets of data we use to analyze our data is usually referred to as the 5-number summary or 5-point summary. These include the minimum Q1, Q2, Q3, and the maximum value. These can be represented on a box and whisker plot. These are the box and whisker plots for Class A and Class B. The box starts at the Q1 value and ends at the Q3. The whiskers extend out to the minimum and maximum values. The Q2, or the median value, is the line in the middle of the box. Thank you, Grade 12s. Remember to look at the tasks for this section in the Advanced Data Handling Task video. You'll also be able to learn more about data handling on our website www.mindset.co.za/learn. Goodbye.